Hi, hello everyone. So this is an introduction to the unit circle. Okay, so first of all, I've drawn a circle and I'm giving it a radius of 1 unit. Now, what that unit is, it doesn't matter. It's one of something. And that's the important thing. It could be 1 centimeter, 1 meter, it doesn't matter. I'm breaking this circle up into 4 quadrants. Now, let's have a look at this circle. This circle has 360 degrees or 2 pi radians, okay? Depending on which way you like to think about this. I'll talk about it in terms of degrees, but it's easy to convert. So at here we have 0, and at here we have 90, at here we have 180, at here we have 270, and at here we have 360. So it's a full circle. Now, I am going to draw a line in this circle. And this line, because it's a unit circle, has a value of 1 unit. Now, I am going to try and express the coordinates of this point on the line in terms of sine and cos. At the moment, I can express it in terms of an x and y value. I can do that because I know that if I drop a perpendicular down from here, then the distance between the origin and there is some x value, and the distance from there to there on the y-axis is some y value, which means that the angle that's created in there can be given in terms of x and y. Okay, so let's have a look at that and see how that would work. So let's have a look at the sine of this angle. So let's say the sine of this angle is equal to opposite over hypotenuse. And similarly, the cosine of this angle is equal to adjacent over hypotenuse. And as you can see, when a number is over 1, it's just that number. That means that the sine of theta is actually just the y component. And that also means that the cosine of theta is the x component. So instead of writing this in terms of x and y as a coordinate, I can actually write it in terms of cosine and sine. And I can do that for any coordinate along this because I'm referencing the angle that makes it. Now, that is very important because, as you might be aware, any coordinate in terms of x and y in this first quadrant will be positive because these are all positive numbers and these are all positive numbers, which means that the cosine and the sine of any angle between 0 and 90 degrees has to be positive. Not only that, but let's see how we could get the tan of the angle. Well, tan is just opposite over adjacent. Opposite is y, adjacent is x, but we know that y is sine and x is cosine. So also, because both of them are positive for any value here, x and y, it means the tan is also positive. So they're all positive here. So the sine, cos, or tan of any angle between 0 and 90 will always be positive. Now, what happens when we move over here? Well, when we move over here, the y values are all positive and the x values are all negative. So what that means for this is if you have a y values that are all positive, that means all the signs are still positive. So all the signs are still positive here. However, the x's, the cosines, are negative. And because sine over cosine gives you tan, and one of them will be negative, that means the tan is also negative. So only the sine value of any angle between 90 and 180 will be positive. The tan and the cosine will be negative. When we move down here, what do we see? We still have a negative x, which means cosine is still negative. The sine of any is also negative, but when you have two negatives divided by each other, you get a positive tan down here. And you can see what happens here. The cosine is positive here. So all the values for all sine, cos, and tan between 0 and 90 are all positive between 0 and 90. Between 90 and 180, only sine values are positive. 180 and 270, only tan values. And 270 and 360, only cosine. You can check that on your calculator, but that is the basis of the unit circle. It is on page 13 of your log tables, as you can see. They give you a pared down version of it, just showing you the basics. Now, obviously, there's a lot more to it than this. There's a lot more detail we can get out of it, but that's the construction of how it works. And it's important you know that.